Greetings and happy day, happy midday. I guess it's happy afternoon out here on the West Coast. And today I'm going to be talking about how to improve code quality. And just as a bit of a closing the loop on last week's Facebook Live, I had promised you that I was working on a post about last week's topic, which was where do product backlog items come from, right? What's the life cycle of a product backlog item? And sure enough, got that blog post live. So if you go over to agilelearninglabs.com and look at our blog, the current blog entry, the one at the top, is called Daddy, Where Do Product Backlog Items Come From? So go check that out. All right, today's topic, code quality. So I want to look at things that we can do to improve code quality kind of by peeling back some layers. And, you know, code quality is one of these things that it's really important, and yet we're really suffering in industry. It's almost an epidemic, poor code quality. One of the symptoms of this is that if you look at where is innovation happening, by and large, innovation's happening, in startups, right? Startups are doing all these exciting, innovating things. And to my way of thinking, that kind of doesn't make sense. If you think about it, the big established companies should be doing lots of innovation because they've got access to markets, they've got capital, they've got lots of, people, they've got technology, they have all these tools. And so they should be able to out-innovate all these little companies that don't have any of those resources. But the one thing that they also have that the little startups don't have is technical debt, right? Most existing companies with existing products have technical debt, often mountains of it. I have the privilege of working with lots and lots of companies, and I can tell you technical debt is absolutely an epidemic, and it causes real problems for the business. It slows us down significantly, makes it harder to react to changes in the market. It makes it slower and much more expensive to release new things in our product. It's a real and significant problem. It even makes it harder to attract and retain great talent. And of course, startups have almost no technical debt, so they can move really, really fast. So what can we do about it? Well, at a first layer, there are some things that we can just have our teams do, right? We can just create product backlog items for these things, and we can ask the teams to do them, and they'll do them, they'll build them, and put them into production. It'll make things better. The first off is fast build, right? If it takes a long time to build our product, well, then we tend to do it less often, and lots of changes tend to get batched up together, and problems tend to be much harder to find, and everything takes longer. So investing time in your build system will result in better quality, because the developers are getting much faster feedback about, hey, did the changes I just make, did I even build? Does it even work? And we can integrate code from different people much quicker, so we can find conflicts much quicker. Turns out integration is one of the fundamentally hard things in software development. So right along with fast build comes test automation. If tests are manual, they are expensive, they are slow, they are error prone. We tend to not do them very often. And so, things go a long time before they get found. Problems do. And there is a classic chart about the cost of a bug related to how long it takes between when it's introduced and when it's found. And it's a classic exponential curve, right? If I'm a developer and I make a typo as I'm typing and I see it and I hit backspace a couple of times and I fix the error, right, the time to detect it was almost zero and the cost to fix it was almost zero. If I'm in a compiled language, right, and I code for 10 minutes or so and then I run my compiler and the compiler says, nope, you made an error. Okay, well now I have to look at the error code and go to that line of code, think about what's going on, and make a fix, and that may have implications for some of the other lines of code, but still not too bad, right? And it's 10 minutes from when it was introduced until it was found, and maybe it took me a few minutes to fix it. Push that out to code that gets pushed to production 6 months after it was written, and then problems are found then, wow, that gets really expensive, especially if lots of people have been making code changes over those 6 months, right? We'll spend weeks just in a finger pointing exercise before we even get it to the person who knows how to debug it. So test automation pays for the cost of creating it very quickly because it makes testing fast, easy, and cheap. So test automation will naturally lead to higher quality code. And then taking that to kind of its natural next step is continuous integration, continuous deployment, right? Wrapping fast build with fast test, and possibly even fast push out to production. So, and these are things, faster build, test automation, continuous integration and deployment. These are technologies that are well known. These are not cutting edge by any means, and you can just implement them. They're honestly, they're not that hard. It's just a matter of, okay, we're going to have some engineers do the work to roll this out in our system. The next layer I want to look at gets a little more interesting, because now we're going to look at like social technical practices that make a big difference. So the first one is coding standards. Having some agreed upon standards for what is good code in our environment. And boy, this takes some work. But the big win is if my code looks like your code, I can understand your code, and you can understand my code. I can expand, change, and debug your code. You can work on my code, and we're not likely to introduce problems. Whereas if I can't understand your code, I'm more likely to make an error. The only problem, so then once we got coding standards, well, then we need some way to kind of enforce them and kind of keep them alive. Hey, David Parker, how you doing? It's good to see you. And so code review is a common practice to help us reinforce our coding standards and propagate, learning and education. All right, if somebody makes a mistake, we want to detect that mistake in a code review, correct it, but more importantly, do the learning and the knowledge sharing to help them understand why that wasn't the best way and what's a better way and all of that. So code review is awesome, except that the way it's usually implemented, it introduces delay. Because very often organizations will say, oh, you have to have a code review before you can check in your code. Oh, goodness. Well, now all the other stuff that we just talked about, fast build and fast test and all that, comes to a screeching halt because we have this human step where somebody's got to look at my code before I can check it in. So a couple of ways around this. One is to not make it a gating function. Hey, if you've got code that's ready to check it in, right? Run it through the build, the test, and all that. And then, yeah, we'll batch up code reviews and see how we can, fix up that code and make it even better. Maybe we'll do them every couple of days or something like that. It's still, though, right, leading to some delay. Because if I write some code, push it to production, and 2 days later I sit in a code review, it's going to take you time to, maybe look over the couple of days worth of code. It's going to take me time to remember, oh, what was I doing there? And so we want to do it more frequently so it gets cheaper and easier and faster. Maybe every day, maybe twice a day, maybe continuously, right? We call this pair programming. So we have two developers developing code together. Wow, we're getting all the benefits of code review in real time. So that's awesome. And then to take that to its logical extreme is mob programming, where we get the whole team sitting together, working on one story at a time. I know, when I first heard about it, I thought it was crazy. But I'm good friends with some folks who are very active using mob programming and having amazing results. Llewellyn and Falco, for example. And then finally, the last social technical practice I want to talk about is test-driven development. Right? This is writing a test before you write the code. And a lot of people think this is a practice that's all about testing. Hey, because we create all these automated tests, which we do, and they're good. But really, it's a design practice. If we have to define the behavior of a piece of code by writing tests that will verify that behavior first, well, then when we go to write the code for that particular behavior, we're going to write it in a way that is more direct, cleaner, more obvious, because we've really had to think about what is the behavior and what are the edge cases and stuff like that, because we had to write automated tests first. So those are some social technical practices. So now I want to move on to kind of managerial business social practices that will lead to higher code quality. First off is, as a business, valuing the system itself, right? The product that we have is a system. It's a bunch of code. It might be, a room full of servers as well, whatever it is. And that system is an asset of the company. It's a value producing asset. And just like we want the teams to be answerable to sales and, strategic folks like the CEO and all of that, marketing, and delivering things that are creating value as demanded by those parts of the organization, we also want some people, such as like system architects, who are important stakeholders, business stakeholders for our teams as well, because they are well positioned to look out for the health and the inherent value of the asset that is our system. And so if we start to value the system itself, we're likely to start doing things that are going to increase the value of that system as opposed to decreasing it, right? Technical debt decreases the value of our system. Related to that is value and quality, right? Not only do we want people answerable for and teams answerable for what new behaviors have you created, right? What new features, what bugs got fixed and all that. We want them answerable for the quality of the work that they did. So having technical people giving technical feedback in sprint review, as well as kind of sales and businessy folks giving feedback about the business direction of what the team's creating. Really important, right? Because we're creating a culture that values technical excellence and quality. And then finally, in this domain, is valuing medium and long-term gains. As human beings, we have this unfortunate cognitive bias where we drastically overvalue short-term gains and losses and drastically undervalue medium to long-term gains and losses. So pop quiz, should I emphasize the thing that is going to lead to the greatest value being produced over the next 6 months? Or should I emphasize and support the thing that's going to deliver the greatest value in the next week at the expense of not being able to deliver the greatest value over the next 6 months? When I phrase it that way, it seems like by and large we should want to create as much value as we can over the longer period of time, right? That's the bigger win. However, as human beings, we way overvalue the thing that's happening right now, the deadline we have this week. And that leads to technical debt. We take shortcuts. We do things that are expedient right now, but are going to cost us down the road. And that takes business people and managers and leaders to shift what we value, what we put focus on. And urgency is a good thing, right? So things get done, but we really want to value long-term value creation. So that leads to the next set of practices or values, which is valuing the people who are building the system, right? They're not just, widgets to create code. They're actual human beings that we care about. And we want to value the learning that is necessary for them to start to develop mastery in their craft. And so we need to do that through active, sanctioned activities, training, things like that. Also, through creating sanctioned and supported social structures in our organization, things like guilds and communities of practice. An example of this would be if I have an organization with lots of Scrum teams, and let's say each team is a cross-functional team that has a back-end developer and a front-end developer and a database developer and a tester and a documentation person, or whatever the mix is. And at many teams that look like that, I want to create a company-sponsored, supported, sanctioned gathering place, social structure for all of the back-end developers, and another one for all of the front-end developers, so on and so forth, where those people get together and make decisions together about the direction of the back end, and architectural choices and tool choices and sharing best practices and all of that. Because by creating social structures in the organization that explicitly promote knowledge sharing, learning, and mastery, we're going to see direct results in the quality of our product, the quality of our code. And then the final thing I want to leave you with is this. Given that as an organization, we want to have business agility, we want the ability to react quickly to business needs, and we want to be able to continue to build and maintain and modify and expand our product at as low a cost as possible, right? So we don't want technical debt. We want to drive that down. And the people building our product, by and large, they want to build a high quality product. By and large, they really detest technical debt, right? It really bums them out. They really want the opportunity to build high quality. So why aren't they doing it, right? We want them to do it. Why aren't they doing it? Well, there are two ways in general to try to get people to do the things you want. One is to apply some sort of pressure, right? Carrots and sticks, right? You get in trouble if you have a bad code review, or maybe you get a bonus or something if you have a really great code review. But much more powerful than pressure, either as a carrot or a stick, is simply asking, well, why aren't they doing the thing we want them to do already? Right? What is in the way? Why is it hard for them to do the thing that we think is the right thing? And then as leaders, as scrum masters and managers and folks like that, our job is to ferret out what are those resistance places? What are the policies? What are the behaviors? What's going on in our organization that is making it hard for people to make better choices and engage in the behaviors that we'd like them to? And then our job is to go knock those down, remove the points of friction so that it gets really easy for them to do the things that we want them to do. All right, so that's probably enough for today. Thoughts on how can we improve our code quality. It's really awesome to see some folks hanging out with me. That is super cool. So Muller and David, and I don't know if it's Travis or Lisa, but hey, it's really great that you hung out. And then, as I mentioned, my last week's topic was where do product backlog items come from? And as promised, I just published a blog post on that topic. So head over to agilelearninglabs.com and check that out. And of course, if you or somebody you know is looking for Scrum training, go to agilelearninglabs.com. We're happy to help out there. Have a great rest of the week. I'll see you next week.